Algebra 2 regression practice. This video should be watched after the 2-4 video, possibly after doing the 2-4 lesson, although if you're having some trouble with regression, maybe you could have jumped on here to get a little bit more practice on regression and linear regression or linreg on the calculator. So let's suppose you're given this set of data right here. This was just the easiest way that I thought I could present this data. I have already entered this into my calculator. Let's review how you do that. Oh, actually, before we do that, everybody should do the following. If you have a newer calculator, which would be most of you, you can press mode, and you want to make sure that your stat diagnostics are on. You see how mine are already on? If your calculator is new, they're probably off. So you just arrow down to it and arrow over so that you're hovering over the on and press enter, and that'll turn stat diagnostics on. If you're using an 83 and I think even an older 84, this may not appear in this menu. So what you do is you press second 0, that's the catalog, and you can arrow down to the D's. This is all in alphabetical order. Arrow down to the D's until you come to diagnostics on right here. Select that and press enter, and that'll turn the diagnostics on. I didn't mention it yesterday, but when I ran linreg, it gave me an A value, a B value to be plugged in for those letters in the equation that's given, that's in slope-intercept form. And then it said R squared and R. And I'll talk about that in a second. You're going to want your calculator to provide what those values are. And having the diagnostics on is how you do that. Okay. If you have to reset your calculator for some reason, it defaults back to off. You'll have to remember to turn it back on again in one of these two ways. Okay. So again, I have already entered that table into my calculator. The way you get to it is you press stat enter, just stat enter, and right away you get these values. Now, do you know that you can just overwrite, right? So if you're doing one problem and you've got some things in here and you want to do a different problem, all you have to do is just type right over the top. Okay. I will show you how you can clear list and delete list after we do this problem, but you can just type right over the top. I don't want to change it, so if I just type a 7 here, it stays the same. If you typed something else, it would replace it. Okay. And also at the bottom, right, so I have 11 ordered pairs here. When you get to the 12th one, you see how it's in parentheses there, it's saying 12. That means you've entered 11 things. It's kind of a good double check to go to your table and go 1, 2, 3, 4, 5, and count them down and make sure that you have the same number of items. If you have a number in one of these and not the other, you'll get an error, right? Obviously, you've made an error because ordered pairs have an X value and a Y value. All right. So again, the way we do this then, and I showed you in the previous video how to look at them on a graph. I'm not going to do that today, but if I wanted to, I could change the window to incorporate these values and push graph. And as long as my stat plot is on, that's the plot 1 is on, you'd be able to see the points. You don't need to see the points in order to run regression. You got points in here. We go stat, calc, 4, enter, 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 enter. And this just gives me that equation. Now, I don't know if I emphasized this good enough yesterday, or I keep saying yesterday because I made that video yesterday in real time, but in the previous video. But this A value is this A value. This B value is this B value. So we could write this and it would be, if we would tell you on a test what to round to, we'd say round to the nearest something. Let's say round to the nearest 100th. Well, that's 1.54. That's the slope that goes in here for A. And it's negative 0.22. You could write the equation y equals 1.54x plus negative 0.22 or minus 0.22. Right? Now, again, notice that it gives me an R squared value and an R value. We're going to focus on the R squared value only because the other regressions that I mentioned in the previous video will only have R squareds. So we're just going to look at that. The R is called the correlation coefficient. R squared is the something determination. I can't remember what it's called now. But anyway, we're going to look at the R squared. I'll just always call it the R squared value. And here's the deal with R squared. The closer R squared is to 1, the more linear the data is, the more closely fit to this linreg situation it is. So this would be really tight. An R squared value of about basically 0.99 is very strong. That's almost 1. And if it were 1, that would mean that it's exact. It would be exactly aligned. But this one's a little bit off. But I'm telling you, if we looked at the points, and I said I'm not going to do that because I want to keep this video short, but if we looked at the points, they would look very linear. They would look like a very positive correlation, given that the slope is a positive number. But not exact. So correlation is a correlation, and it's really close, but it wouldn't be exact. Okay? Now, take a look at this. If I go back to my stat edit menu, I want to show you how to delete things. So if you just sit in the first spot there and you press delete, things just shift up. Now think about this. The difference between the word delete and the word clear. Do you have a good working definition for each of those words, and are they different? Clear, like think about if I said clear the classroom, that would mean everybody get out of the classroom. If I said delete the classroom, that would mean like the classroom's not going to exist anymore. Okay, so as I sit in this cell right here and I press delete, it makes the 9 go away. If I press delete again, it makes the 18 go away. Think about what would happen though if I arrowed up to this and I press delete. This is for L2. This is for the list 2. If you press delete up here, I think you have to press delete enter actually. Don't do that. But if you press delete, you're going to delete the list. You don't want to do that. There are ways that we can fix it. If you accidentally do it, bring it to me and I'll show you how to bring it back. But it would be better if you just don't push delete up there. You can push clear enter and it will clear the list, right? So if I just go to here and I press clear enter, it clears the whole list. But don't arrow up to the heading and then push delete because it will delete the whole list. Now, what I wanted to show you is simply if I put 2 points in. So the 0.8 -2 and the 0.57. And then I run stat, calc, for, enter, 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 enter. Notice that the r squared value is exactly 1. Again, ignore the r value. We could talk more about that at another time, maybe in class. But notice that the r squared value is exactly 1. That means that the line that passes through these points is y equals -3x plus 22. So I put -3 in for A, 22 in for B, y equals -3x plus 22. Okay, and why is the r squared 1? Well, because given just 2 points, the line is going to be exact. There is a line that passes through any 2 points that you can pick. Okay, so the r squared would be 1. Now, as soon as I add a third point, and I'm just going to do this randomly, and hopefully it doesn't lie on the same line as the one that I just picked. If I enter a third point, 3 and -20, and then run linreg. See, that's terrible, right? Your calculator still does the best, let's say the best it can, right? It still does a calculation to come up with the best trend line called the line of best fit. And the slope would be -21.4. That goes in for A. The y-intercept would be 3.1, rounded to the nearest tenth. That would be for B. Wait a minute. Why is that A plus BX? That was weird. I've never seen that before. Let me just pick a different number. Yeah, stat, calc. Oh, I think I ran this one. I think I ran that instead of the other one. I've never seen that before in my life. Okay, back to normal. All right, now, again, the r squared value, this one's actually much better. I actually happened to click on the graph and you saw the 3 points. They're fairly linear, so the r squared value is high again. On that previous one, it was 0.31. That's terrible. That's like almost just scatter plot everywhere-ish. Okay, your calculator still does the calculation. We could still provide an equation that would be the line of best fit, but it really doesn't have much meaning when it's a low number like that. The closer it is to 1, the better. 0.94, that's pretty close. This is a fairly strong correlation. Okay. Now, again, why isn't it exact? Why isn't it 1? Well, because it's not exactly a line. As soon as I add a third point, it'd be a fair coincidence that if I actually picked a point that was on the line, I didn't, and therefore it's going to provide that line best it can. Fairly correlated, but not great. All right, I think I've made this video long enough. Thanks for tuning in.